In this module, let's look at the SQL insert and delete instructions. Let's start with the insert. An insert instruction will insert a single row of data into a table. There are some different ways in which we can code an insert instruction. Let's start with the simplest. We're going to use the tables that we created in the Create Table module, Employee and Sales Order. Let's start first by inserting a row of data into the employee table. We begin, of course, with the keyword insert. We then have to tell SQL into which object do we want to insert data. And so we're going to specify into and our table name, which is employee. In the simplest form of the instruction, we then put the keyword values and provide a list of values to insert into each attribute in the table. The list must align to the order in which the attributes exist in the table of the definition, with one exception. If you recall, in the employee table, the very first attribute was employee number, and it utilized an identity constraint in order to serve as the primary key of that table. When an attribute has an identity constraint, skip over it when you're using an insert statement. We would never insert data into an attribute that has an identity constraint. That attribute is being managed by SQL Server, and its value is set by SQL Server. So therefore, the first value we'll put in will be a value for the employee first name. And so I'll put in John. I then have to specify a last name, because that's the next attribute, and an employee start date. When you enter dates into SQL, you have to put them in single quotes, the same as you have to for text data. So for John and Doe, we put them in single quotes because those are both text data types. One had an nvarchar data type, the other had a varchar data type. Date data types also require that the data be put in quotes so that it knows that what's inside of that is a date format. If you don't put quotes around it, it will still insert a date. However, what it will do is it will take that value as an arithmetic expression, calculate a result. So in this case, it would be 12 divided by 25 divided by 2014, which is going to give you a small decimal number, and then convert that to a date, which of course is not going to convert to 12/25/2014. Always remember to put dates in single quotes. And then of course we have to specify a salary. The salary field is a decimal field. Numeric values are not put in quotes. We can type them in, but since it's a decimal, we should include the decimal component. Let's code one other insert for the employee table. This time, instead of inserting values into every attribute, we're only going to insert values into some attributes. Minimally, using this method, we must include every attribute that has a not null constraint. The only attribute that we specifically put a not null constraint onto was the employee first name, and so we must have that. If we want to add another field, another attribute, we then list it and separate them by commas. This time in our list of data, we're aligning the values to the attributes we specified. So Jane will map to employee first name, and we'll give Jane a salary of $150,000 that aligns to her salary. Let's go ahead and execute these instructions, but before we do, Notice that every SQL instruction is color-coded in that blue indicates that SQL considers it to be a reserved word. Red indicates either an error has occurred or it knows that it is data. When I execute both instructions simultaneously, I get two messages that are displayed. Each says one row affected, indicating that both rows inserted successfully. Let's see what the employee table looks like now. This will display the contents of the table. You notice there are two rows inserted, employee number 1, which is John Doe, and employee number 2, which has a first name of Jane, and no last name. The last name defaults to a null value because we didn't insert anything into it, and that particular attribute had a null constraint. We didn't specify a null constraint, did we? Well, what happens is not nulls must be explicitly stated. If a field is not explicitly stated as not null, it defaults to permitting nulls. Notice the employment date for Jane is the date in which I created this, which is inserted into the employment date field because we had a default that of the get date, which says pull current date. Let's insert a row of data into the sales order table now. This time I'm only going to put a value into the employee number field. I don't need to put a value into the order number field because that's got an identity constraint, and I'm going to skip over the order state. What value can I put in? Well, I can only put in a value of 1 or 2 because the employee number must match an existing row of data in the employee table, and of course I only have 2 rows of data in the table now, one with employee number 1 and one with employee number 2. So I'll select employee number 1. I'll go ahead and execute that. I now have 1 row of data in the sales order table. I have 2 rows of data in the employee table. Let's talk about the delete instruction. The delete instruction deletes data from a table, but it does not eliminate the table itself. The table will still exist. It's just the data will be deleted. To use a delete instruction, we have to specify which object we're going to be deleting from. And so I'm going to start by saying delete from the sales order table. If I execute that instruction, what it will do is it will delete every row of data that existed in that table, for which I only had 1 row of data in that table. If I delete from the employee table, it will delete every row of data in the employee table. If you want to only delete specific rows, you need to give it a qualifier. The qualifier is specified with a where clause. In the where clause, what we need to do is define the condition with which, when there is a match, it will delete that row of data. And so, in the employee table, I'm going to delete those records where the employee number is a 1. Here we deleted just employee number 1, but left employee number 2. Let's look at the contents of the table. John Doe is gone, but employee number 2 still remains. Finally, if you want to actually get rid of a table, deleting will not get rid of the table itself. It will only get rid of data. In order to get rid of an object, we have to use a drop instruction. The syntax for a drop instruction is the keyword drop and then the object type. In this case, the object type is a table, and so we have to put in the keyword table. We then have to specify the name of the object we are dropping. I want to get rid of both the employee table and the sales order table. So let's try it. I'm going to execute first the drop instruction for the employee table. I got an error. Notice the error message. It says, could not drop object employee because it is referenced by a foreign key constraint. SQL maintains referential integrity. Because we have a foreign key from another object pointing to the employee table, it will not permit me to drop that table. In order to drop the employee table, I must first drop the sales order table. That executed successfully. Now I can go ahead and drop the employee table.